Hey, how's it going, everybody? All right, so for this week, we are going to be covering Python APIs or just API theory. We're going to be covering some different tools for working with APIs to help you get a better understanding of what they are, their use case in the industry, and then we're also going to be adding in error handling into our NetMiko backup script. So we'll finish up our Python theory with some error handling in NetMiko. And then we'll move into APIs, the overall concept and theory of APIs, how they work, and then we'll get into some tools on how you can actually interact with APIs. Our objectives for this module are going to be to write error handling into our NetMiko backup script. We're going to be covering an overview of API theory as well as the HTTP protocol, how we use that and some of already its built-in methods and codes to interact with our network controller through a web interface and application that has exposed API. And so we're going to be making API calls to that. And then we've got a few test cases out there on the internet we're going to take a look at. I want to cover the benefits of tools such as curl and postman, which are tools that are used to test APIs. So we can run tests against the API, see what example outputs are going to look like, make sure that they're working correctly before we finally move into production and run it in a production environment. We're going to be covering the Python request package, and that is going to be the package that we use for interacting with APIs. Okay, so an overview for this lecture is we're going to be covering Python error handling first so that we can finish up our NetMiko backup script and make sure that it doesn't error out when we run it if it does encounter errors. Then we're going to be covering API theory. More specifically, we're going to get into REST APIs because that's going to be a majority of the one that you're actually going to interact with. We're going to be covering the HTTP protocol, the different methods and built-in codes and status codes that we can use to actually let us know if there was an error in our API, if the server's having a problem, or if we entered something incorrectly. We'll be covering different tools for working with APIs, the Python request module. I will be doing a demo with the tools that we cover as well as Python requests, and of course, I'll do a quick little demo on finishing up our NetMiko backup configuration script. And then finally, we'll move into our summary. Error handling. It's important to build error handling into your code. So what does error handling mean? Well, as most of you have seen as you're kind of walking through and getting familiar with the language, that a lot of things can go wrong with depending on what it is that you're trying to do with your code. What error handling allows us to do is it allows the code to continue executing even though it potentially encountered an error. So a good example use case would be for our NetMiko backup script. Let's say we were running that script against 100 or even 1,000 devices. If one device errored out with an authentication error, we would not want the entire script to fail and subsequently fail every network device backup after that. We just would want the script to continue running and do some kind of handling of that error so it makes it visible to the end user that we did encounter a problem. Error handling is accomplished with the try statement, which kind of puts you in an if loop, but it's similar to an if loop. So we do try, and then we'll actually put what we want Python to try doing, and then we'll write in some of our different options, which would be things such as accept, which we can then use to write in, hey, you can accept this type of error, such as authentication error if you encounter it, timeout error, input error from the user. It depends on what you're trying to accomplish with your code, with what errors you could actually potentially see when you're executing it. So our options are going to be to accept, which accepts the error and allows it to continue running or performs whatever we code into that accept statement. You've got else, which then kind of boils it into an if then else function. And then finally, which will execute no matter if it errors out or not, it will finally do something. And statements that I like to use as far as error handling is concerned, if I encountered a authentication error, so you can do a few different things. I'll just use authentication error as an example. So if I was attempting to run that NetMiko script against a network device and it failed authentication, I could do a couple of different things, but let's say I have more network devices than just the one. So I would want it to continue going, so I would need that pass statement in there. And then we have a few different options on how we want to act, if we want to actually do anything with that error, because if we don't do anything with it, then it just errors silently and nobody ever knows that it happened. So if this backup script was erroring out on a single network device for, it could be weeks, months, whoever knows how long, because it's not erroring out and you've got all the rest of the backups are showing up and we don't even know that that device is erroring out. So we can do a print statement where we just print to this the terminal, letting the user know while they're running the code, hey, I encountered an error when trying to do this with that device. But what if we're running this job at night as perhaps maybe a cron job or a scheduled task? Well, then we could do something like potentially create a list of all the devices that failed, and we could do a few different things. We could save that as a file so that you could come in every day and check it and see which devices failed. You could send it off as an email, or as we start to learn with APIs, we could also send a API call in a post form to perhaps a chat channel or something, and then it could produce all the devices that failed to back up.
Okay, so the first item on our agenda is to add error handling into our NetMiko backup script. So I'm already logged into the SDN VM, I've got my terminal opened, and I have the same virtual environment activated that we activated in the previous module when we actually created this script. So I'm in an essence of a repository. I'm pretty much sitting at the same point you are, because if I back all the way out into my SDN demo repository, I can do a git status, and you'll see that everything's clean. My working branch is clean, even though I've got a few more folders and files and things like that. Everything is still up to date with my GitHub repository. And if I cat out the SSH Cisco Pi, which is our backup script, you can see everything's the same as we left it. I've got my lab Cisco device up and running, so I'm going to go ahead and just execute the script, make sure it's still working. Alright, whoop, see, I have an error. File exists. Oh, so I will go ahead and remove backup config. Alright, make sure it's not here anymore. Alright, cool. So nothing starts with a B even in this directory. Alright, so let's go ahead and try and run the script again. It's actually a very good example to show how, even having that file exist errors out the code. And that's not what we want. So that would be a perfect example of something that, a feature that we could add into the script is that it does not error out if there is a file already with the same name. So it looks like it ran successfully. Let's go ahead and see if it's here. Alright, it is, and if I cat out backup config, let's see. Alright, and that is good stuff, sweet. So you can see that I have successfully backed up the device. Alright, so we want to add in error handling, and I gave you 3 requirements. One of them was a timeout, an SSH, and an authentication exception. So if we jump into, and let me just go ahead and clear, because I saw that it does not like to get the last line. My screen recorder seems to kind of cut off just like that last half inch. So I'll import NetMiko, and then I'll run dir against NetMiko. And you can see that at the top I already have a couple of exceptions, which are basically errors or error handling that we can add in. So we've got this NetMiko authentication exception, which is looking pretty promising for our authentication. This NetMiko timeout exception, which looks promising for our timeout. I just noticed this as I was doing the lab, but there's a second authentication exception in there, as well as a second timeout exception. Very curious, because never really had to check on those all that often. And then I also wanted a SSH exception, so I'm assuming that's going to be in this SSH detect. Do I let's see, SSH auto detect, SSH dispatch, there's SSH exception down here. So let's check out that SSH exception, and that would be dir netmiko.ssh underscore exception. And it looks like all of our exceptions are in there, so we can go ahead and probably just import directly. So just for good measure, let's check out this, do a help on netmiko.ssh underscore exception. And let's go ahead and just check out the first authentication exception. Exceptions raised when authentication failed. For some reason, it may be possible to retry with different credentials. Other classes specify more specific reasons. Okay, so that's why we have different reasons available to us, because you can apparently write the authentication pretty granularly so that it tells you what actually went wrong. So let's go ahead and pop back over to Adam here, and I'm going to go ahead and from netmiko.ssh underscore exception, we'll just try the first one. We will import, we'll go ahead and just start with the authentication exception right there. So I'm going to copy that, import authentication exception. And now we need to actually write in that error handling. So we're only doing one device, so I'm going to do a try. And there you can see it drops me as a different indent, so I'm going to copy this out of here, and I'll come back up here and probably actually just delete out these two lines so I don't have a lot of white space. Hit enter again, and now I'll paste down, and it's going to try to initiate that connect handler and pass in device, assigning it to the variable C. And we want to add in our first exception. So I'm going to do except, and then in parentheses, let me just make sure I got that right, because I don't have this set up, this Atom set up for my full dev environment, but this should take. So except authentication exception, and I will print to the terminal an authentication error occurred while connecting to, and then I'll plus, and I'll do device IP. Okay, so I'll save that, and I'll come back to my terminal, quit out of here, clear my screen, and I've got to remove my backup file, and let's go ahead and try and run that SSH Cisco again, but this time I'm going to pass in bad credentials, and let's see if it errors out or if it just prints to the screen that I passed in bad credentials. So I will type in my email and a bad password. Okay, so this did not work. It says name IP is not defined. Okay, this isn't what I was expecting to see, actually. It did throw the exception up here, netmiko SSH exception, but then the print statement also errored out, and it said name IP is not defined. Device, let's see here. So let's go ahead and try that again. I'm going to type in just user and bad password. All right, so this is what I was expecting to see. So here we see an authentication error occurred while connecting to 192.168.1.10, but it's still errored out with these tracebacks, which is not what we want. And it says name error, name C is not defined, and that is because I still tried to run it right here. I tried to pass in c.send command show run. So this portion executed successfully, but then it still tried to continue to execute the rest of the script, and that's not what I want. So what I'm going to do now is add in the pass statement, which when this authentication exception is raised, it should print this to the screen and then just pass the rest of the script with this pass statement, otherwise known as kind of failing silently. If this was multiple devices, it would then move on to the next device to back up that next device. So I've saved that. Go ahead and come up here, and let's see if we just get Alright, so it is doing that because it is, it's because I'm not in a loop, and I don't want to put the fix in here because I don't want to teach you bad stuff. So it's because I'm not in a loop. I only have one device here. And realistically, if I was running this against multiple devices, this would be in a, like, for loop. So for device in list devices, and then I would try and connect and back them up. This pass statement would then pretty much just pass over the rest of the code, but since I'm not in a loop, it doesn't really do that. So for this code, this would fix it. I was debating on whether or not to show that, but I figured why not, because just keep in mind that what this break statement does is it pretty much exit the entire script, which is what I have to do since I'm only using one device. But if I was doing this in a loop with multiple devices, this break statement would actually stop the process, which would not be what I want either. Oh, never mind, it doesn't like the break statement. Oops. Let's try... You know what? I'll move it. So I will move this. Up to there. And that way, the rest of this only executes if that connection was successful. That should fix it for us. All right. And then, otherwise, it's going to print an error to the screen, because again, we are only working with one device. So I'll clear that. Let's try that again. Ah, there we go. That's the results we wanted. So the script did not error out, but what it did do is it just did not execute the rest of this because this was not successful. Instead, it raised an authentication exception and printed this message to the screen. So if I come back here, clear my screen. Let me just make sure I don't have a backup. Okay, cool. I don't have any backup, so I'll clear the screen again. And this time I will run it successfully by passing in my real credentials just to make sure that it still executes without any issues. All right, cool. And if I cat, it should have backup conf. All right, so it worked. So that's one exception that we've added in, but we have more. So I can, I need to remember I can always come into Python, import netmiko, and do a dir on netmiko, and it was ssh_exception. And it looked like I could also dir netmiko, and I saw netmiko authentication exception. Yep. So netmiko authentication exception. Let's see what we hold in. I'm going to keep it as is because we're making an SSH connection, and I just like how it says .ssh exception right there. instead of from NetMiko import authentication exception, because this is kind of implying that this should be an SSH connection. So I'm going to leave that as is. But we had other ones that we could import as well. So I'll do a comma, come back over here, and I'll do a dir against NetMiko. Or I could just use what I have up here, save some time. So we have timeout and SSH. I wanted SSH. I'm just going to add the rest. I'm not going to demo them because in order to do that, I would lose connectivity to my lab device, which I do not want to happen because then I have to go bust out a console cable in order to fix it. And so SSH exception, and we'll print an error occurred connecting to device via SSH is SSH enabled. And then I will do my last, which is going to be, but I have to import these as well. It's SSH exception, and I believe it was NetMiko. Or is it just timeout? So I'll just go ahead and run with the first one here. I'll add a short little message. The device timed out when attempting to connect. Alright, so there we've officially written error handling into our script. I've saved it. Although I have not lost connection, on the CSR 1000V, you know, you'll basically have that console connection since it's a virtual router. Mine's actually in my rack, so I would have to go console into it and everything in order to lose the connection. I don't have two set up on it right now. So I'm not going to demonstrate the SSH or the timeout. In the lab sheet, I did give you instructions on how you can test both of those. One of them is by shutting down the interface, and the other is transport input none, where you can disable SSH from coming in through your VTY lines. But what I'm just going to do real quick is delete my backup, and then I'll run the script again, just to make sure it does not time out or error out in a way that I don't know yet. Alright, so it didn't error out. If I cat backup conf, alright, sweet, so it's still working. Now, oh, bummer. I just made those changes on the wrong branch. So in your lab, I'll go ahead and I'll just delete it out. It's no big deal. So what I can do is I can come in here and use this as an opportunity to teach you a few coding tricks. So I will comment out everything that we just did right there and add this back in, which just puts us at our original scripts. This is where we originally were, and now I will copy this. And now what I'm going to do here is I'm going to come in and do a get status. So I do have some changes. but I'm not going to commit them. I'm going to remove that backup conf, get status again. Alright, SSH Cisco has been changed. So I am actually going to come in here and just copy this out, and I'll just open up like Notepad++. Alright, sorry about that. Seems like Notepad++ had something to update, but here we are. So I'm going to go ahead and paste that in there so that we don't lose that code, and then I'm just going to delete this out. So I wanted to show you what this looks like. Let me just run that get status again. I removed backup.conf. Okay, clear. Awesome. List. Alright, backup's gone. Clear my screen. Get status. I don't know why it's still, oh, deleted. So I pushed it the last time. And ssh.cisco has been modified. So I'll do this first one. I'll go ahead and just update my repository now. So I'll do a git add and stage everything. And now if I do a git status, you can see I've deleted backup.conf and modified SSH Cisco. So I will then do a git commit with a message of removed backup file and restored backup script to original form. Alright, git status. Alright, so now I'll git push, and it's asking for my username and password to GitHub. It's pushing everything to my GitHub. Alright, sweet. And down here you can see the whole reason I'm doing this is we've got this main, and that's not what I wanted. So here, down here at the bottom, you can see I'm working on the main branch. I can create a new branch right there, but you really should learn to do this in the command line because you will not always have, oh, and get status. Alright, I'm working on the main branch, origin. You won't necessarily have like a graphical tool such as Atom available to you at all times. Like I have a server deployed in my environment right now where I have a script running on it, and if I'm working on that and I need to use git, I do not have Atom. I have to use the command line. So that's why it's important that you learn how to use the command line. So I'm going to create a new branch called git branch, and then I will just call it lab. I'll just call it my name. And I'll git checkout to that branch. Switch to branch Sheldon. Alright, git status just to verify. I am on branch Sheldon, nothing to commit, working clean. Okay, so I could make my changes directly right here if I wanted to. And I'm going to come over to Atom, and it's already swapped me to branch Sheldon, you can see. I can swap back to my main branch or branch Sheldon. So I'll stay on branch Sheldon, open back up Notepad++, copy the code, and I'll just overwrite all this. Okay, and I'll save it. If I come over here and do a git status, nothing to commit, working tree clean, that's not true. Did I save? No, I did. Alright, it's picking that up. Just to demonstrate real quick what we were talking about. So now if I do a git checkout to main, git status, now I'm on the main branch, but if I cat SSH Cisco, okay, so that's what happened. Interesting. So I've got to go through that over again. I truly apologize. I must not have saved it or something. So I still got that there. So I can do it Control Z and just back out of that and save it. So I'm on the main branch now, and I've saved that to the main branch. If I swap back over to my Sheldon branch, it is still showing it as Cisco.py. Modified. All right, let's go ahead and just I'm on the main now, so we'll try this one more time. Just gonna put that in there for my message and clear my screen, git push. That's why. Okay. Am I still on git status? The current branch Sheldon. Git checkout main. Git status. Alright, git push. There we go. It is overriding everything I'm doing. I don't know why it's doing that. Okay, interesting. So, try this again. I'm on the main branch. Save. I'm going to do it all through Atom right now. Stage all, because I think going back and forth I might be confusing it. And removed error handling. Commit to main. Don't push it. Alright, sweet. And clear my screen. SSH Cisco. Okay, much better. And git status, I'm on the main, clear. Git checkout Sheldon. Alright, git status. And cat SSH Cisco.py. Okay, so changes are not there. So now I'm going to come back over here. And I've swapped to branch Sheldon, as we can see. Remove all that. Now let's try adding this back in to branch Sheldon. Save this. Cat. Clear my screen. Alright, it's added the error handling in there. If I do a git status. Alright, now we're moving. I don't know where I got switched around. Okay, so now what I'm going to do is I'll just do it from right here. When you do the push from the command line, you then need to go in and open up a pull request, but I'll go ahead and show you how to do that real quick. And what I'm going to do now is I'm on branch Sheldon. I'm not on the main. So I'm going to stage all of these. And then I'll commit added error handling for authentication, SSH, and timeout. And then I'll commit to Sheldon. And now what I will do is come down here and notice it no longer says push at my screen recorder will probably cut that out, but it no longer says push, it says publish. So what I'm going to do is I'm going to hit publish, and then that pushed it to the repository. So now if I come over to my repository for module 7, recent pushes, compare, and pull request. So now you can see I now have two branches, and I'm going to do compare and pull request. And then I'm going to open a pull request. Create a new pull request by comparing changes across the two branches. So what I'm going to do here, see, it looks like I had some failed branches. That's what I was having problems with. So I will write added in error handling for authentication, timeout, and SSH. And now I will create my pull request. Alright, so now I have a pull request open with myself saying, so if I come back to our script, SSH Cisco, you will see that there is no error handling built into the main branch. And that is because I now have an open pull request with myself where I can select it because I own this repository. Open it up. And there's the pull request comment, added in error handling for authentication, timeout, and SSH. And since I own this, I would now have to review the main branch with the changes that developer made, and I can merge the pull request and merge pull request number 1 from Swanso SJ Sheldon branch, and I will confirm the merge. So now if I come back over to my code, I should have opened that. I might have just brought in that one branch. Oh, there we go. See it again. Module 4, SH Cisco. Okay, I need to open another pull request to merge it to the master. I must have opened that one incorrectly. So what I will do is swap back to this branch, Cisco SSH, pull request, new pull request. Yeah, so I just merged in that branch. So what I want to do is Sheldon to the main. There isn't anything to compare. 0 files changed. That is interesting. Main is up to date with all commits from Sheldon. Did not try switching the base for your comparison. This is interesting. Let me just go all the way back in. I don't know where I got this repository all confused with itself, but I did it somehow. I'm going to come into module 4, SH Cisco. It's still not there. Lord. So let's try opening a new pull request. Branches, tags, and ranges. Create new pull request. Compare main to main. Sheldon to main. Maybe I need to go backwards the other way. Main to Sheldon. Alright, so here it is. So it would remove those. So it's seeing it that way, but it's not what we want. We want to do main, Sheldon to main. This is driving me insane. Because it's seeing it one way, but it's not seeing it the other. Merge pull request number 1 from Swanso SJ Sheldon. Showing one file changed. Did I not finish this pull request? That's what I'm wondering. Okay, well, I'm gonna see if I can't. Where is it? I need to merge the two. Able to merge. All right, so let's just finish, go backwards if we need to. Pull request. Let's see what happens. Update main with Sheldon. Create pull request. The branch has no conflicts. All right, merge pull request. And confirm merge from Swanso SJ to main. Let's see if that did it. I may have just done it backwards when I created that pull request. So now SDN demo, I'm on main, module 4, SSH Cisco. All right, is Sheldon, does it have error handling? It does not. So I just blew out our changes, no problem. Sorry, this one's taken so long. So let's go ahead and do a fetch, which is at the bottom, and I will pull. I'll try opening that pull request again. So I'm still on my branch Sheldon. Added in error handling, I'll save it. Stage all. Error handling added. Commit. Sheldon, and now I will push the branch Sheldon. It's pushed. Back over to Safari. Main, module 4, SSH Cisco. All right, cool. Sheldon. All right, now let's try that pull request one more time. New pull request. Compare Sheldon with main. There we go. Now it's picking it up. Don't know what that was about. Able to merge. So now I'm going to compare Sheldon to the main. And now you can see it removes these and adds in our error handling. Much better. So let's go ahead and create the pull request again, and we will say added back in error handling. All right. And now I'll merge the two. Confirm the merge. See if it's saying now branch can be safely deleted. So I'll delete the branch. Come over to my code. Module 4. And there we go. I don't know why I got all turned around, but it did. So sorry it took so long, but that is how we go about updating our code, and we just got to go through a little bit of troubleshooting. Nothing wrong with that. And I updated the repository, opening a pull request with myself, letting myself know what changes I made. If you were collaborating with others, you would be telling the repository owner, hey, these are the changes that I made. They would review your changes and then decide whether or not they want to merge your changes with the main branch.
Okay, so APIs, I've been speaking a lot about them, and we really need to cover what they are. So APIs, there's the full name right there, Application Programmable Interface. So what does that mean? It's really just a logical interface that is built into the application to either accept data or provide data to whatever process it is that we're running. So in terms of software-defined networking, we have three key elements to software-defined networking. We have a web application, which is used for a user to interface with the controller, and that is going to speak on the controller's northbound API, because that web application, you can kind of think of the controller as the center of it, and the communication northbound goes to the application, which then goes to the end user. If a configuration change was made or something needs to be retrieved from a network device, that would be over the southbound, kind of thinking in it as a down way down to the network device. That would be your southbound API. And all these are just ways to interact with these different systems, interact with each other in a programmable fashion. And it offers a lot of vendor interoperability. So for instance, let's say we have a Cisco software-defined networking solution, and we have a ServiceNow ticketing or ITIL library. If there's an error that occurs in that software-defined networking system, we could set it up so that the software-defined networking system automatically makes an API call to ServiceNow, opens a ticket, and pages the on-call network engineer. We've got two different types of APIs. You've got synchronous and asynchronous. In a synchronous API, it still works in the request-response model, but it waits for the response before continuing on with its process. Your book gives a really good example of this in, I believe it was YouTube, that when you were uploading a video, formerly in YouTube, when you were uploading this video, you could not do anything else on YouTube until that video was finished uploading. Now that's not the case, so they've changed that to more of an asynchronous format where it does not need to wait and processes can continue to run in the background. Three different kind of types of APIs that we're going to be talking about. Main one is going to be that REST APIs. I'm not going to spend too much time on SOAP and RPC. They are APIs that you'll work with. Those would be more along the lines on the southbound interfaces. And since we don't have like a full software-defined networking lab that we can work with, it's really difficult to demonstrate that and see it in like a lab fashion. So the REST APIs, those are going to be your HTTP APIs that kind of live on a web application, or they're built into the web application, and they follow the same rules as HTTP, where we make a call to the host and then we have a URI, which is our identifier of the resource we are either trying to update or get information about, and we'll see some of that when we go into our demos. Simple Object Access Protocol, otherwise known as SOAP, that is works in XML format. It returns your data in XML. I put JSON as REST, although you can use others. That is kind of the preferred method to interact with REST APIs and receive your data, just because JSON's really easy to work with. It's very readable. What SOAP allows you to do is interact with, like, let's say a application that was built in Java or the .NET framework, and then that could interact with, let's say, a Python application. So SOAP allows us to kind of do a translation in between there. Remote procedure calls, those are XML. I've seen those on, and specifically on Cisco Nexus devices, where if I make an API call to its netconf API interface, I will receive back the RPC reply, and it will be, my reply will be in XML format, and then I can use that reply from the network device directly to interact with that data. REST APIs. So these are built pretty much, REST APIs, anytime I see REST, I think HTTP. Because we basically took HTTP, considering that's how all of our web applications are being built and how really most applications are being built nowadays is using HTTP. We found that we could just kind of build the APIs into the HTTP application, or the server, if you will. And we can use the built-in HTTP methods of get, post, patch, put, and delete to retrieve information with our get, provide information such as our username and password with post. I left patch and put in there because they are included, and that would be more if you wanted to, like, let's say, update something. That would be a patch, or add something to a table, like a database, that could be a put. And then if you were to delete something, that's one's pretty self-explanatory, where you would be deleting it out of the web application and or the database. And then we've got CRUD down there, and that's going to be covered in your book under the REST APIs, REST API chapter. And CRUD is just kind of a term that's used to reference some of those HTTP methods. So create, that would be, that'd be something like patch. Read would be like a get. Update, that could be put. And then I've got update in there twice. I believe that's because it covers patch and put for both the updates, and then delete, which translates directly with the delete statement. So there's where our CRUD comes from. There's two U's in that CRUD. Some of the elements and features of HTTP are Uniform Resource Locator, otherwise known as URL. So when you navigate to a website, they've kind of built it in to be, no intervention needed from the user. You don't need to know the full path of the URL that you're trying to reach. You can usually get to it via a link or something like that. But that host, which would be, let's say, example.com, that is the host. Anything that comes after that, that is going to be your resource locator, the path of the resource that you're trying to reach. And then you usually have different parameters that are put into your request, into your, like on your web browser in your URL section where you put the URL in. So you may see some things such as like a question mark with a name equals. Well, those are different parameters, and most of it was built in so that it requires no intervention from the user. But when we're making API calls, it's very important because you need to know what resource it is that you're looking for and what you would like to do with that resource. We've got our headers, and headers are information about the conversation. So we can say what type of data that we are accepting. So normally I would put that in application JSON format. We could specify the content type where I'm passing it JSON, our authentication, which that's very big with APIs. So we don't just do API calls. They aren't just open so that anybody can run whatever API call they want to any API. If you did that, that'd be a huge security risk. So we do have authentication built in the same way you would any web application. Difference being is it does offer, basic username and password authentication, but you don't want to have to input your username and password every time, especially if you're using something like a dual factor authentication, which is really common today, because your token expires every time you use it. So if you were making multiple API calls, two-factor authentication just does not work with automation. So what they've done is you can use your username and password to generate a token, and then use that token for any follow-on API calls. That token will usually have a lifetime, depending on how it was set up. The administrator set up the application will depend on the lifetime of the token. And then sometimes you've got different keys that you can have built in. For example, I know on Fortinet firewalls, I can add just a strictly REST API admin, and instead of a username and password for that administrator, they will just have an API key, and then they are only allowed to interact with the API. We get our responses in a formatted fashion, whether it be JSON, XML, YAML, which is why we covered those different Python modules, because we can then use those different modules to interact with the data that we got back from the server. Webhooks, which are known as reverse APIs. We're going to be doing a lab next week that covers a little bit about webhooks. And what a webhook basically is let's say we have a software-defined networking solution in a data center, and one of the routers or switches goes down. What we can do is have the software-defined networking application send a HTTP post request to, let's say, Microsoft Teams or Cisco WebEx, and then we could actually post that error to a team chat, such as the network engineering team chat. And this isn't just local to just networking. APIs are the new hotness. They are everywhere. So pretty much if it is a web application or has a web interface, it has an API that you can interact with it. If it does not, I'm not judging on the tool or the application, but I'm going to say they're falling really behind, and it's probably not a very good application just because everybody's demanding those now, just because it offers a lot of those vendor interoperabilities and a lot of automated processes. Then you got pagination, which limits the amount of output that you could get in a request. So if you're interacting with a controller that has thousands of devices on it, and you want to see all of your network devices, the output of that could be quite large, and you could have unwanted consequences or effects. So what pagination allows it to do is just give a specific amount of output at a time. And then you could also request a specific output. So let's say you did that call and you only retrieved back 5 devices, but there was 1,000 in there. Well, then you can then just alter the offset for that pagination and say I want to see everything in page from 5 to 25 or something like that. And then you also have key set based, which would be kind of similar to the dictionaries in Python or JSON, where you have key value pairs, and you can just use the key set to say, all right, I want to see this key, whatever the key is, I want to see that information. And that's what pagination allows us to do. You also have things like rate limiting and request limiting. I run into that problem a lot, especially when I'm working with my Fortinet APIs, because I'm really the only one who's kind of been diving into that. So when I'm making multiple API calls over and over, a lot of the times they'll say, hey, that's too many requests. You've reached your limit on how many requests you can enter in a specific amount of time. So you do have those features built in as well. HTTP, otherwise known as Hypertext Transfer Protocol. So nowadays, most things are written with HTTPS, which is just Hypertext Transfer Protocol Secure, in which we just encrypt the information to and from the server as it travels across our network or the internet. Built into HTTP are different HTTP methods, such as get, post, patch, put, and delete. And that really allows us to interact with our web application and do anything that we need to. So we can update information, we can add information, we can remove information, and we can retrieve information. There's really not much more that we would need to do with it. And then we've got our HTTP headers, which are very big when it comes to doing API calls, because you need to build out your headers and you need to specify a few things in there, such as how are you going to authenticate to this server? Is it set up for basic username and password authentication? Does it generate a token if you authenticate with that username and password, or does it require an API key? You can use API keys between two systems and provide one of them the key for the other system. That way these two applications can talk to each other. You've got your host, which is going to be the actual server that we're requesting the information from. The URI, which is going to cover, what resource that we actually want. Your headers also contain things such as cookies as well as accept, and that's telling the server, hey, I will accept the response back in application JSON, for example, or application XML. And then you can also specify the content type that you're telling the server, hey, this is the body of my HTTP request. The content type is JSON, so it's in JSON format. Now the server knows how to actually translate and work with the information you provided to it. It has built-in status codes, and each of those status codes has kind of a status code group where we've got groups of 100, 200, 300, 400, 500. First digit indicates, what the status code group is, and then the second two would actually identify the code itself. So the 100s are going to be informationals, 200s are going to be successes, 300s are redirects. Let's say the resource that we're looking for has moved to a different URI, URL, so it would then produce a 300 redirection, or maybe it's moved to a different host. But those are things that are actually built into web applications. You've got 400, which are client-side errors, and 500, which are server-side errors. I don't like the term on that because if the client enters in the resource wrong, like the URI, if they have a typo in their URI or something along those lines, that could show up as a server-side error in like path not found or resource not found, something like that, when really it's more on the client side where that's a client error, and that's where kind of those client and server errors they can get a little confusing if the error is actually on the server, but the error code is the error is actually on the client, but the error code that you return says, oh, it's a server error. May not always be the case. So those can be just a little too definitive for my liking. And then I added a couple common status codes here at the bottom. 200 OK, which means our API call was successful. 400, which is a bad request. 403, forbidden. That means you're not authorized to get the resource that you're looking for. And then we have 404, not found, means that the resource that you're looking for was not actually found. All right, so we've got some different tools for working with APIs. From the Linux command line, we can use curl or curl. And curl is just a bash application that is the Linux command line. It is already installed on your SDN VM. Most graphical Linux distributions come with curl already pre-installed for you, and that allows you to perform HTTP requests from the command line. You can even fill in your headers, your authentication data. Almost everything that you need to actually build out an API call, you can do with curl. So it offers all of the options of Postman, which is going to be our graphical tool. It's easily available. It's usually installed on most Linux systems by default. Biggest thing about it is some people don't like applications that don't have GUIs, but GUIs are slow. So if you can kind of stomach working through and learning the command line tool curl, I do feel that they are a lot quicker, and curl is going to be more readily available. Let's say if you run across a Ubuntu server with no graphical, like GNOME isn't set up or anything like that, the desktop environment isn't there. So then you would be forced to use something like curl. But then we do also have Postman, which is a graphical application, so it gives us all the pictures that we like, buttons, lists, menus, all that good stuff. And what I like about Postman is it allows us to build out collections of common APIs. So if we were building out APIs to Fortinet firewalls, we could build out a collection of Fortinet firewall APIs. If we were building a bunch of API collections to Cisco's DNA Center, which is their software-defined networking solution for the LAN, we could build out an entire collection of Cisco DNA centers, and we can build collections within our collections. It's basically just a filing system. We also have these things called environments, which we can activate an environment, which will allow us to keep, common variables that would be included in those collections. So if I'm still in DNA Center, that means that my host is actually not going to change. So I could then create a variable for that, or I could create a variable for my username and password and store those as environment variables. And then we just activate the environment, allowing us, not to have to update or enter that information in every time. You can also store dynamic variables with tests. It does require a little bit of JavaScript. I'm not going to say by any means that you're required to know JavaScript. I just know the tests that allow us to save that token. It's only 2 lines of code, and it's available pretty much anywhere, but I will be including it in your answer sheet as well so that you can throw that in your own Postman environment. And then it gives us these things, these code generators, which is a great starting point. That's where I say Postman is meant to test APIs, not work with APIs. To work with APIs, you want to use something like PowerShell or Python, something that we can interact and work with that data in a programmatic way. But our code generators in Postman, once we get the APIs to work, or you've tested them out fully, then you can just use one of the code generators as a kind of kickoff point to start building out your Python script. So the Python package that we're going to use to interact with APIs is the requests package. So that's going to be installed with pip install requests. It is a Python package installed with pip. Make sure you activate your virtual environment and set up a virtual environment. This is where we get into those virtual environments are going to be more required or more important, because now we're installing, as you can see, lots of packages, and we don't want those to affect our native Python installation. They're used to interact with APIs, and they allow us to interact with them in a programmatic way. So we can use all the things that we've learned about Python up to this point: classes, if then else, if and else statements, while statements, so we can loop through things. We can do conditional matching against the responses that we get back. We can also provide information back to the server based on the response that we got from them. So request just uses HTTP methods, very similar. All it's doing is HTTP calls, whether they be get, post, put, delete, and then you provided a body, fill in your header information, and that's kind of how you start building out your Python requests. I put this in here because this is very true. This is where this is such a young and new technology as far as the way we work with different systems and interact with networks, that not all companies are even close to getting here, but it requires a lot of creativity, and that's where you you have to keep working with Python and building out your skills, because then as you start to build your Python toolbox, or I'm not even going to say toolbox, I'm going to say your paintboard, your Python paintboard, because then you're getting all this creative ways to work with the data and whatever it is that you're trying to accomplish with Python. So creativity is a very big portion of this. I think almost anybody could write a GET request, but if you don't know what it is that you're trying to do and what is available to you in Python, then you're not going to be able to be fully creative and actually utilize some of these tools to interact with your controllers and your applications in a programmatic way. I'm emphasizing this one again, and that's non-built-in vendor integration. So what do I mean by that? So you may purchase a solution, and it could be a software-defined networking solution, or it could just be like a firewall, a load balancer, whatever, and it offers a web interface to manage that. Well, sometimes a lot of these vendors will work together, so it could have built-in integration. So Fortinet could have built-in integration with, let's say, Cisco ACI, which is their SDN solution for the data center. And if those integrations are built in, that means setting it up is actually quite easy. But if you have something that was not built in, then you can use Python and this request library to make them work together. And it's really awesome, and that's how we're creating a lot of these automated processes, chat bots, where help desk some help desk people are starting to lose their job because now we can just reset our passwords from a chat bot, or we can open a ticket with a chat bot. We're trying to automate a lot of these workflows, as the demand keeps growing and growing and growing for technical skills in the professional workplace. They're not going down; they're going up.
To demonstrate APIs, I like to use, there's a couple of kind of fun websites out there. So the most basic form we're going to use is an API server that returns a joke. So I've left two options in your answer sheet. I was not aware that the Chuck Norris joke database had explicit jokes in there until someone said, hey, just to let you know, this is the joke I got. So if you're okay with explicit jokes, go ahead and use the Chuck Norris database. They are a little bit funnier. But I'm going to go ahead and just use the dad joke API. So if I just come over to Safari real quick, I can just go ahead and type in dad joke API. It takes me right there. And then here's how you can actually use the dad joke API. Like, here's the documentation, because documentation is very important when it comes to APIs. So it even gives you examples of curl, which is what we're going to start with. I'm going to come over here and grab the base URL, which is HTTPS. iCanHasDadJoke.com. Copy that. And we're going to work with curl first. So I'll just do a curl, paste in the name of the website, and then there you can see it actually returned a dad joke. If you want a job in the moisturizer industry, the best advice I can give is to apply daily. Haha. They're kind of corny jokes. But that's really the basic a basic API call right there. Is I just did curl, the name. I used all of curl's default settings. You can always use your help option to see what your options are. You can use the man page to view the manual page about curl. So I will do a. I think there was it even had an example on the site, so let's just move over here, and it's the H. I'll do this this H option, which alters the HTTP header to accept our output in application JSON format. So let's do curl, and I'll just go ahead and paste that in there, accept that, and probably should have grabbed the site as well. And let's see what this looks like. In there, it gave us our results back in JSON format. So there you can see the ID of the joke itself. Dad, can you put my shoes on? I don't think they'll fit me. Don't get it. But it also gives us our status code, which is a 200 OK. I can also do these verbosely, which verbosely means, because there's a lot of things that happen in the background when you do things like an API call, run a script, run any command. So doing it verbosely basically just means I want to see everything that happens behind the scenes printed to the terminal. So this is going to fill my terminal up, but I'll go ahead and do a double V curl and paste in our dad joke. Whoops. Does it just want one V? That's not what I wanted. Okay. Oh, it's because I'm still using man. That'd probably help. And that filled up my screen, so I'm going to clear again, run one more time. So what we see here is the connection to the API server. So here it's up here, it's connecting to the server on port 443, and it's just giving us some information about connecting. So here we can see the connection was set, and we were connected. Here's all of our HTTP SSL stuff so that we are secured. So here's our SSL handshake, the server certificate to encrypt the data, and what I wanted to get to was here where we actually start seeing our HTTP headers. So here you can see I've got host, the name of the host, the agent. I am using curl. If you were using a web browser, by now they pretty much just kind of list all the web browsers in there. So it would say, Safari, Mozilla, whatever browser it is that you're using. And then here's the response HTTP header with a status of 200 OK, the content type it gave back, which was text plain, the content length, my cookie, and then more HTTP headers, and then finally at the bottom, my joke. So let's run let me clear my screen, and we will run the curl verbose again. But let's alter our headers. Okay, so here we now see something different. Accept application JSON. In the response, you can see I still got a 200 OK, but now on the content type, it says application JSON because I told the server I would like to get my response back in a JSON format. So it gave it back in a JSON format, giving me the ID of the joke itself, and the status code of my request. And that is an API call in its most basic form using curl. Your book has a couple other more common options that would use, such as the D option for passing in data. We just saw the H option for altering our headers. Then you got things for ignoring the certificate if it's insecure, because that's very common, especially when you purchase appliances from vendors. You can store and receive data. You can send in your token or your authorization. But that is the basics behind curl. So now let's move on to Postman. Postman is installed on the SDN VM for you, so you can just click here and open up Postman. I'm going to go ahead and just go over to my native installation of Postman on my Mac, just because I have it all set up. But here's the dad joke again. This is Postman. Postman gives us a graphical tool to interact with API, so I will launch it actually over here on the SDN VM because it should be blank, which was what you're going to see when you initially launch it, since mine is already set up. So here you can see I'm starting up Postman. Alright, so this is a blank installation of Postman, and actually they've came out with an update since then, so realistically I should come in and update this software, but this update just came out not too long ago. But here you can see history. We can create collections, so I would create a new collection and call it software defined networking. Create. And now I have this empty collection. And what I'm going to do is I'm going to come up here, hit new, request. And for this, I'm going to call it dad joke. And returns dad joke. And I'll put it in my software defined networking collection. So add it to software defined networking, and I'm going to be doing just a simple HTTP GET. Let's go ahead and grab that URL, that host URI, that base URI. And you'll remember I was able to run it with curl without making any alterations. Whoops, where did my postman go? Should be showing up here on the left. And so I'll just go ahead and, without making any changes now, do a very simple, I just punched in the URI. I've specified that it's going to be a GET request, and I will send. All right, cool. So it gave us back basically an HTML page, and that's not what we want, right? Curl gave us back at least in a text format. But let's go ahead and take a look at our HTTP headers and see what those are set to. So I clicked headers. You can see nothing showing up, but it says 7 hidden right there. So I'll just click this 7 hidden. And I've got accept set to that. So what I'm going to do is uncheck that. And I'll do another key of accept. And I'll just type in app, and you can see it gives me my options as I started typing in application. So I'll do accept application JSON. I unchecked this exception, which is accept all. Not asking for any parameters. It doesn't require authentication, so I'll just go ahead and run this request again. And there you can see it gave me back my information in JSON format. So there's the joke ID, the joke itself, and the status code. Over here on the right, you can also see it gives us the status code of 200 OK, the time it took for the request to complete, and then the size of the body. I can save the response right here if I want to. I can take a look at what cookies the server assigned to me for the connection, and I can run this request again if I want to. Send, and I just got another joke. Simple API call. Another thing I can do is I can come over here, and you'll notice that there's this code section. But before I get there, I just want to finish this walk around, and that is with environments, because you'll notice I spoke on environments, but we really won't get to those until the next module when we start working with some Cisco software-defined networking solutions, in which we would have a use case for environment. And those are up here on the right, so you can see I don't have an environment selected. I'm not going to create a new one right now because we just don't need it. I've got this little eye where I can take a look at my environments, but again, I do not have one at the moment. But I just kind of wanted to point out that those are there. Your collections are on the left. You can create new collections, so even inside of my software-defined networking collection, I can add a folder, and I'll do a joke APIs. Create, and then I'll add the dad joke to the joke APIs folder. Alright, cool. So that was manipulating the headers, and we didn't pass in any parameters. I can select this code option right here, and here you can see it even gives me the long version of my curl request. On the left, I've got all the options as far as how would you like this request, this API call that you just did, and it defaulted to curl for me. So even if I copied this out, came over and pasted it in here, you can see it works, and I still get my joke. I could have left my cookie out, it just depends, and it added everything in long format, so instead of the H option, and we just used actually header. Keep on forgetting that it's hiding Postman from me. But what we want is Python. So scroll down here, and you can see we've actually got two options, HTTP client and request. We are working with the request module. So here you can see it just spit out what I wanted in Python. So I'll come back over here, clear my screen, and get out of module 4, and I'll make a new directory for module 5. Go into module 5. List, you can see that it's empty, so I will touch joke.py, come back over to Atom. You can see I now have the new module 5, joke.py, which is empty, so let me open up Postman again. I apologize if you hear Selena in the background, she's sleeping. I'll paste that, I'll save it. And then I will run Python joke.py. Module request. I'm still in my virtual environment for the backup script, so I will deactivate this. List, and then Python 3 module venv, and I'll just create a new one since I'm in a different directory. Source ven bin activate pip install requests. Clear my screen, create my requirement.txt file since I just did an install. Alright, sweet. So now let's try and run that again, python joke.py. And there you can see it returned my joke, and I did not make any alterations to that code. So now I can come in here, and you know what? I don't feel like having my cookie in there. So I'll just delete my cookie out, and the only header I'm going to be passing in is application JSON. Let's take a look at this code real quick. So what happens? I import the request module. I set a variable of URL to my dad joke API server. Payloads, I created an empty dictionary. For my headers, I create a dictionary with only one key value pair, and that is accept application JSON for my HTTP header. And then I've got response request.request, and then I'm using the get method, passing in the URL that I defined up here. I have some keyword arguments such as headers, and I'm making that equal to my headers dictionary. And then I've got another keyword argument for data, which I am setting to my payload dictionary. And I'm assigning that the value of response, and then I am printing response in a text format. So why don't I go ahead and clean this up a little bit. I'm going to add one more, and I'm going to do import. I'll do a from pprint, which stands for pretty print, import pretty print. And instead of printing response.text, I am going to pretty print response.text. Let's see if that changes anything. A little bit. Not quite as pretty as we'd want it though. So let's come back over here, and instead of that, so I'm passing in that I want it in application JSON format, but I haven't done anything with that yet. So what I'm going to do is I'm going to import JSON as well. Now pretty print, I know just from working with Python, it should be already good to go. So if I wanted to test, I could even do a, just pop into my interpreter, import pretty print. All right, that one works. Let's see if it's got JSON as well. Alright, so JSON and pretty print are both native, so I don't need to do a pip install with those. So I'm requesting it back in JSON format, and it's giving it to me in JSON format. So what I'm going to do here is do response JSON equals response dot JSON, or I'm sorry, response JSON equals JSON dot loads response. I'll save that. So my joke.py, and then I will pretty print response.json. Let me save that, and let's run it again. Did I forget to import something? I saved it. JSON object must be string bytes, but not response. So I'm getting a type error. So now we know that we have different options. So if I remember right, I must be passing this in incorrectly. So what I will do is do a response.json, and I'll just do that. I'll save it, whoops, and run it again. Boom, that's exactly what I wanted. All right, so what I did is I just loaded our response or into a JSON format, and then I stored it as response.json, and then I pretty printed response.json to the terminal. This one's a little bit short, but you can see that it just gave us our first value, and then it gave us the second value. I think that formatting is just due to the joke, so if I clear that and run it again. Oh, no, it's apparently gives us the joke in 2 lines on all of them. But it's a little bit easier to read than getting everything in 1 line, and this will be better demonstrated when we actually start doing some bigger API calls. So the next API server I wanted to introduce you to is for your extra credit assignment. So I posted an extra credit on this module because you now have all the tools to complete this extra credit assignment. And that is if I go to deck of cards, or I'll just do a search for it, deck of cards API. This is a fun little website on the internet. It's free, deck of cards API. You could actually set this up yourself if you wanted to, because you can see at the bottom that you can view it on GitHub, so you would be able to contribute to this if you wanted to. Or you could set it up yourself because it's open source. And all it is an API server that mimics a deck of cards. Very easy documentation. As I stated, really, documentation is key when it comes to creating API calls, because you're not going to know the path to the request that you're looking for, the different parameters that you could choose. So I am going to go ahead and just draw a deck of cards real quick. So here you can see shuffle the cards, and it's at the bottom, add deck_count as a get or post parameter to define the number of decks you want to be used. Blackjack typically uses 6 decks. The default is 1. So here we have https deckofcardsapi.com API deck new shuffle, and then this question mark deck_count equals 1. That question mark indicates to me that is a parameter. The parameter name is deck count, and we are setting that to 1. So I'll just go ahead and copy this out. I'll come over to Postman, exit that, and then I will make a new folder, and that will be deck of cards. Create the folder, new request name, shuffle new deck quantity 1. And I'll put this in the deck of cards folder, save to deck of cards. So I could remove this deck count here as a parameter if I wanted to, because it's added at the bottom. So when I pasted that in, it automatically picked up that question mark, deck_count equals 1, and it put the parameter in here. So if I wanted to alter this parameter now and say I want 2 decks, I could just do that, and it automatically updates the request right there for me. So I will do, what did it say, 6 decks for a typical game of blackjack. So I'll do 6 decks, and then I will shuffle this new deck with 6. Send. I got my response back in application JSON. Did I say that is the accept? Nope. Okay, so it defaults to JSON for deck of cards. That's kind of nice. And here you can see it says success equals true, meaning the deck of cards was successfully shuffled. I got a status code of 200 OK, but here it gives me a deck ID. So now that I've shuffled that deck of cards, I have been given a deck ID. So I can now use that, and if I come back over to deck of cards, draw a card. And actually this is a good use case for us to start working with those environments actually. So I can create a quick environment for this deck of cards, because here it's saying, giving me the path to draw a card, and then it's giving me this deck ID kind of as a variable, and then draw, how many cards would you like to draw? Here I'm saying 2. So let's go ahead and make a draw card request. In order to do that, I'm going to create a environment. So I will click New, Environment, Deck of Cards. The variable is going to be deck_ID. Initial value, I will go ahead and just pass in, whoops, deck ID. Initial value, I'm going to set that to 0, and the current value, I'll leave that alone as well. So let's just go ahead and add that real quick. So now we've got the deck of cards environment up here. So I can click that and see what my environment variables are, and I can add more if I want to. So I'll cancel that, close out of here. I'll select the environment from deck of cards right there, and then I will click my view, and you can see I've got a variable of deck ID with no value assigned to it yet. So in order to, I was going to save this for authentication, but we'll go ahead and do a quick example right here. Is what I need to do now is set my return for deck ID to my environment variable, which requires a little bit of JavaScript. But here on the right, you can see they have code snippets. So it says set an environment variable. I'm going to click that, and it says PM environment set variable key. And I may need to cheat a little bit, but my variable key should be deck_ID. There we go. And then the variable value is going to be the response from here, and I have to cheat a little bit, so that's why I have my Postman environment open. So let's see if I have my tests right here for it. I do not. Generic authentication, I should have a test here. Okay. So I'm going to copy that out, and you could just do a search engine for this. I mean, it pops up almost everywhere because I still don't know the code off the top of my head. But I'm going to put that down and paste in variable JSON data equals json.parse response body, which is the response body right here. And then let me just cheat again. So this one uses a little bit different, postman.set environment variable token, and then it says JSON data.token, and that's, we'll see this in next week's lab, but here we basically want is JSON data._deck ID. So we will do remove those quotes, and we will do JSON data.deck_ID. Save that, and that should be good. So let's just go ahead and run this again now. Come back to my parameters and deck ID. Okay, so it's going to parse the response body, look for this deck ID, grab that value, and then assign it to the deck ID environment variable. So let's go ahead and send that off. Alright, so now I got a new deck ID. Let's see if it actually set it in my environment variable. And I can check by doing this quick look, and there it is. Deck ID initial value is none, but it assigned this 79 AEQVA, my deck ID, right? So now we can use that as on a follow-on request, and we will just go ahead and do a new request. Request name, we will do draw card, and I'm putting it under the deck of cards folder. Save to deck of cards, come back over to the deck of cards site, and to draw a card, we're going to copy that out. And did it say this is a, okay, sweet. So it's got this deck ID, and we now need this to reference our environment variable. So to do that, we do a double curly braces, and then we put the name of our environment variable in there, and you can see it even pulls up right there with the green E letting me know this is an environment variable. And that's, again, double curly braces and then the name of your environment variable in there. It's saying what the initial value is, the current value, and then the scope. And for deck count, for how many cards we want to draw, we'll go ahead and draw 2. And there's that parameter down there, count equals 2. And we're passing in now our deck ID that we got from Shuffle a New Deck, and I should have put quantity 6, but it's okay. And let's go ahead and send this off and see what we get back. All right, sweet. I got a 200 OK, shows my request was successful. And if I scroll down, gives me everything, but lots of images and stuff. So I'm assuming these are pictures of cards. But we can see in there, success, it was true. Gave me my deck ID, and then it has cards, and then a list of dictionaries. So if I scroll down here, you can see the code is 4C, which stands for a value 4 of clubs. And then 6 of clubs. So I pulled 2 cards, the 4 of clubs and the 6 of clubs. And I can run this again, pull 2 more cards, 3 of hearts, 6 of spades. I can still use this code generator and hit code, Python requests. You can see it just pulled this one request for us, which is the draw 2, and it added our environment variable in there. For your extra credit assignment, I would like the game to draw a new deck every time, so I do not want your deck ID hard-coded. Please pull it out of your Shuffle Deck API response, and then use a follow-on API call to draw cards. That extra credit assignment is worth 50 points. It's worth 50 points for a reason, because it's all or nothing. I should be able to pull down your GitHub repository and play a quick game of blackjack by accepting input from me and displaying to the screen what it is I should be doing. So I'm removing the cookies from there. Copying this out. And actually I'll copy out the shuffle quantity. So code, I don't want my cookie in there. Copy, and then I will just do a under module 5 new file, blackjack.py, import requests, import JSON, import preprint, shuffle new deck, deck count 6, so I could even do a DC for deck count equals input how many decks would you like? And then instead of putting that statically equal to 6, deck count plus DC. And this is going to be a number, so I need to string it. For my headers, I'll go ahead and specify application JSON. Accept. Let me put this on a new line for you. Accept. And, I'm going to cheat again. Okay. Application JSON. And then I'm going to still I'll do deck JSON equals response.json, and then I'll pretty print deck JSON. Save that. All right, that's been saved. And blackjack.py, so I should be able to just Python blackjack.py. How many decks would you like? I'll take 3. Module object is not callable. Blackjack preprint deck JSON. Decks would you like 2? Module not callable. What did I do wrong? Okay. I can cheat again. So JSON response. Response. Import JSON. Let's just try printing it. Okay, pretty print just didn't like something about it. Interesting. Okay, how many decks would I like? 2, and then my request is successful. It gave me a deck ID, and here I could come in and I kind of seen this, and I see what the response is. What I can do is, I kind of need that to be in JSON format. JSON. I feel like something looks different. Oh, it still printed it. Okay. So instead of printing now, I'm going to do ID equals deck JSON deck ID. And I will go ahead and print your deck ID is I'll save that. Go ahead and run that one more time. Let me clear my screen. Let's say 6 for a game of blackjack. Your deck ID is null. Oh, that's not what I wanted. Okay, again, some coding tricks. We'll comment that out real quick. And we'll just add back in print deck JSON, save, run it again. How many decks would you like? 6. All right, deck underscore ID, copy that out. And deck underscore ID, deck JSON. Equals deck ID. It should be taking that. Oh, this would help. Plus string ID. So now we can remove those quotes. Save that. How many decks would I like? 6. And there's my deck ID. So I've officially pulled my deck ID out, and now you can see how you could continue to go through and use conditional matching, loops, inputs to create a game of blackjack. So I hope I gave you at least a decent start there. And I think that realistically, I think that covers it for our introduction to APIs. We're not going to be getting into, authentication and all that stuff until next week. So I hope this was helpful. And I'll go ahead and deactivate this virtual environment. I'll clear my screen, and for good measure, I'll go ahead and pop back out here, do a get status. Okay, so it's telling me I've added module 5. I am still on Sheldon, so I'll go ahead and git add, get status. All right, looks like everything was staged properly. You might be wondering, but Sheldon, it didn't add your virtual environment, and you never deleted your virtual environment. That is correct, because I have list all, a get ignore file, and in my get ignore file,
I just use the standard, which comes by default when I create a repository in GitHub, and I choose Python for my git ignore file, and this is what comes by default. It gives you all this stuff, which is common things that you would not want to be included in your Git. And you can see right there, environments, env, venv, which is why I name mine venv, is because I know this is right here, but I could add another one if I chose to name them anything different. So I just wanted to show you that. Where was I? Git status, everything should be staged, git commit with a message, and I will say added blackjack demo and joke API. All right, and then I will git push. Let's see if this one is, all right, cool. So new branch Sheldon was pushed to Sheldon up in demo. Let's see if this one is a lot more better. SDN demo, 2 branches, okay. No module 5, as you can see, pull request. I'll open a pull request with myself, compare Sheldon, which is now new again. And okay, cool. So there's everything I want to. Create pull requests. Added module 5 demo, joke API call, and deck of cards extra credit demo. Create the pull request. Pull request has been created, and now it would be on whoever owns the repository to come in here and say, okay, let me go ahead and check out your pull request, and I'm going to go ahead and confirm that merge pull from number 4, Swan to SJ Swanson. So I'm merging Sheldon to main, confirm the merge. All right, that has been merged. If I come back over to my code, I only have, oh, I didn't delete the branch this time. Oh well, it's okay. But there we can see module 5 showed up, and blackjack, joke, and requirements are now all a part of our main branch. So I hope this was useful for you. I hope you enjoyed the troubleshooting. You know, and that just kind of goes to show that you really just need to get in there, play with it, deactivate, there we go, and experimenting around with the language, making these mistakes, working through those mistakes. That's how you are going to build your skills. All right, clear list. I don't have anything in here. So if anybody has any questions that can't be repeated enough, please direct them towards the discussion board. However, you are always feel free to reach out to me on a message via Canvas, shoot me an email. The quickest way to get a hold of me, however, is going to be through a simple text message. I have my phone with me at all times. You're more than welcome to shoot me a text message. If you require any additional information or need to cover anything, I also usually have my iPad with me at all times, so we can spin up a WebEx and cover anything whenever you would like. So bonus extra credit is on a game of blackjack. It needs to exist on your GitHub. It is a all or nothing extra credit assignment, so either the game works or it doesn't, and it needs to use the deck of cards API to play a simple game of blackjack. I hope you have fun with this week's lab. If you have any questions, please feel free to shoot me a text. Thank you. Summary. So we covered error handling in Python, built that into our NetMiko script so that it's not going to error out when it tries to interact with a network device. We've covered APIs and what we can use, how they're used kind of on the HTTP method side with REST APIs. We've covered SOAP, RPC calls, northbound and southbound, as well as synchronous and asynchronous APIs. Then we covered REST APIs and the HTTP protocol, which we learned about some of the HTTP methods. We learned about CRUD, our HTTP headers, where we specify the content type, what we accept, as well as authentication and authorization using perhaps a basic username and password, a token, or an API key. We've covered some of the different tools for working with APIs, to include the curl command line tool and the Postman graphical user interface tool, where we built out some collections and environments in Postman. We've seen the Python request library and how we can use Python to interact with APIs and then get information back from different servers and interact with it in a programmatic way. And then we even covered a little demo of it where we took a look at Deck of Cards API, some joke APIs that are out there on the internet. So feel free to research different open APIs that are available to you and pick whatever one that you would like the most, or one that interests you, if you will. All right, if you have any questions, please direct them towards the discussion board. If you have that question, chances are someone else in the class has the exact same question. If that doesn't work for you or you feel more comfortable, you can always reach out to me via email or a message in Canvas, but the quickest way to get a hold of me is always to shoot me a text message. I have my phone with me at all times. I usually have my iPad with me at all times. You can just shoot me over a couple of quick screenshots or pictures of what it is that you're seeing, and I can help move you along, or if need be, we can start up a WebEx and we can have a one-on-one session. So with that being said, I leave you to this module's lab. I hope you enjoy working with APIs, building error handling into your NetMiko application to back up network devices, and if you have any questions, by all means, let me know. I'm here to help. Thank you.